Hi everyone, thanks for hanging out. This is going to be a great evening, but I have to give you a little bit of a disclaimer. First of all, I'm going to explicitly thank Phil for allowing me to speak here, because here's the disclaimer. I am not a video expert, unlike most of you. Yeah, I know, big one. Now, although I'm seemingly pretty much out of my depth here, I do have a bit of experience with web acceleration, and I have a bit of experience with public speaking. And when I talk about the technology I'm about to talk about, I always throw in this one as the first slide, as a sort of way to bond with the audience. And I always start off in a dramatic sense, and I always say, ladies and gentlemen, do you agree that slow websites suck? And it usually works, but it's not really applicable today, is it? So I try to find an equivalent for video, and this is what I came up with. This is the slow websites suck for video. And I even asked my 6-year-old, do you know what this means? And he said, yes, that's when Netflix is slow. So it's pretty universal, right? But it doesn't have the same ring as slow websites suck. So I used my imagination, and this is how far my imagination stretches. Right. So I'm going to reframe that initial statement. Ladies and gentlemen, do we agree that buffering is bollocks? Do we? Okay, great. Now, it's all part of this overarching set of, I wouldn't call it 21st century content delivery challenges. It's a lot more recent than that. Like bandwidths are increasing, but also the things we're shoving through the internet is massively increasing, and the expectations are pretty high as well. So one would think, hey, it's only about speed. No, it's not. So today I'll be talking about finding ways to offer stability for video because users are expecting it, and by chance, having a little bit of reduced latency while we're at it. Now, most of the problems in the delivery of online video are either lack of server capacity or lack of network capacity. And the problem is that most people on the web, not only video, also websites, APIs, and other content delivery solutions, they think that if you have a lack of resources, just throw resources at the problem. That's like I see someone nodding really enthusiastically. But that's not really a sustainable solution on the long run from an economical point of view. On a short-term basis, when the house is on fire, yes, add servers by all means. But as the famous poet Biggie once said, more money, more servers, more problems. But what a lot of people try to do is they optimize it, which makes perfect sense. It's a feasible solution, but oftentimes after a while you hit the point of diminishing returns. And what I'm trying to say effectively is, we're going to talk about caching today, which I use the metaphor of boxes. It's just storing pre-computed stuff in boxes for later use. And why not, right? Like, why would you recompute if the data doesn't change? Because I remember I've been using Varnish as a user for the last decade, and in the beginning I saw a lot of people say, isn't that compensating for poor architectural decisions? But it's not. In my opinion, caching is a valid strategy. It's part of your architecture. Because why would you recompute things if the data doesn't change? Like, why would you, like a typical website or VOD segments, they don't often change. Why waste CPU cycles? Why waste I/O? Why waste memory if it all remains the same? So please don't recompute if the data hasn't changed. Right? Still with me? Good. Hi, my name is Thijs. I always have to do the intro, right? Like a little bit of secretive intro. I'm a tech evangelist at a company called Varnish Software. Who's heard of Varnish Software? That's quite a bit. But I always say, like, to be politically correct, there's room for potential. There's potential here. We're a web acceleration company, but most people know us from our open source project, Varnish Cache. Who has heard of Varnish Cache? For those of you who have not heard of it, it is a, dare I say, maybe it sounds a bit cocky, is the industry-leading open source web acceleration technology, powering about 5 million websites. And if you look at the top 10,000, 20% maybe, dare I say. Of course, working at an open source company, you also make a little money, so we do that using Varnish Enterprise. Now, I've joined the company. I've joined Varnish Software 11 months ago, and I didn't know about video at all, so I learned about video the last 11 months. And I'm pleasantly surprised to see that Varnish in a whole, be it open source, be it enterprise, is quite suited for video, and the numbers show that as well. We noticed that the technology that we use, that we build, powers about platforms that have 750 million viewers a month. And then obviously, and yeah, I'm a bit embarrassed to do this, you have to throw in this slide, but I'm going to make it quickly disappear again with people, companies who use it. Some of them we can't really mention because a lot of companies don't like it when you piggyback on their success. But I'm pretty sure that most of you have a subscription with them, and if not, some of our other companies or children have subscriptions, possibly. I hope I said enough and not too much. But anyway, you can follow me on the social media at Thijs Feryn. Because we're at Twitter, maybe you can get in touch with me afterwards. I'll publish the slides on Twitter, via Twitter as well. And you can, like if you're in the front row and you're that kind of person, you can heckle, banter, do whatever you want. I'm fine with that. Also, constructive criticism, I'm fine with that. I'm the author of Getting Started with Varnish Cash. It's not about video per se, but it's a good place to start. And I have a free copy of the book. I'll raffle it. I'll leave that up to Phil. Phil will probably, right? Phil, you'll do that. Now, I'm kicking in an open door when I'm saying that video is quite of a big and broad industry, and I learned that firsthand with my 11 months of experience. I went to these trade shows, NAB, I went to IBC, and it amazed me. But as wide and as varied, and I learned that at the meetups as well, everyone has its own thing going. It's clear that myself and my colleagues were at the delivery end of the thing. And what are we delivering? HTTP. HTTP response is based on HTTP requests. Now, under normal circumstances, this would be your communication pattern. I'm still having to decide if I'm going to go for the left screen or the right one. But let's start off here. The normal communication pattern would be a client connecting directly to a server responding. The problem with that is, and apologies if I'm dumbing it down too much, is that if you have lots of clients, that server is going to come under a tremendous amount of pressure. The kind of caching you can do by using a so-called reverse caching proxy, which is what we do and what most of our competitors do, is you add this little node in between, and both ends here, the server and the client, most of the times have no clue that there is sort of go-between. The goal of the proxy server, the reverse caching proxy server that Varnish is to try to satisfy requests from the client without having to connect to this one, to the server, because the server is obviously prone for heavy load. That's the entire idea. And whenever something is not stored in here, the server is going to be requested with a single backend request, try to keep the load on the system quite low. It's going to respond, we're going to store it, and so on and so forth. Now, this is my 223rd presentation. I'm doing a lot of presentations about caching, and I always see confused faces. And I must admit, I see confused faces in here. So if that is the case, I always have a remedy, and that's my remedy. I always throw in this picture every time I present and talk about caching. Who knows what movie this is about? All right, go for it. Very enthusiastic person. What movie is this? It's The Bodyguard, featuring, let's see if you're, Whitney and Kevin. Indeed. So the metaphor goes, this is reply to video. This is your video platform, and this is your reverse caching proxy. So when in doubt, ever, think about Kevin and Whitney, and you will be just fine. Right? See, a lot of people are less confused by now. So you might say, that's all good, and yeah, the jokes are probably bad, but so why don't you use a CDN instead? Like, CDNs do the job. They do, actually. CDNs are quite good. But I have to say that Varnish is CDN software as well. And you can interpret that in two ways. Yes, you can use Varnish to build your own CDN. And yes, some CDNs actually use Varnish under the hood to build their CDN. So it's up to you if you want a service or a software. I can bore you a half an hour with why you should go for the one or the other. We're not going to do that. Take it as you wish. I'm just going to show you that either you build your own CDN yourself. A lot of companies do that because they already have the infrastructure and they have, like, geographically, it's quite limited where they're active. So it makes sense to not spend a metric shit ton of money on networking costs. But for other companies, they actually use a CDN. A lot of our clients use a CDN. It makes sense. It's global. And what they do is they add a little layer of Varnish locally just to make sure that all these points of presence from these CDNs don't DDoS. That's what some of our clients do. So I don't really cast any judgment. It depends on what you need. But let's continue with the technical aspect of it. Again, 11 months of experience with the technology, and what have I learned? There's this thing called HLS. Who uses HLS still? I want to learn from the experts. I know that MPEG- is also out there. Who uses MPEG- instead? So what's the best thing to do here? HLS or MPEG-? HLS? Is that irony or is that actual? Well, I use HLS. Like I've had this proof of concept where I use my GoPro, do an RTMP stream to a Docker container where I have FFmpeg, and that turns it into HLS, and I have a little layer of Varnish to play around with. So what I learned is that there's this thing called transport segments. This is, and I hope I use the correct terminology, where video gets transmuxed. Is that the word? No? Is it transcoded? Whatever. It gets turned into TS files, and these TS files contain your video. Those are downloaded as requests from a client, and then eventually there's this entry U8 file, which is a playlist that keeps it all together. Those are the things we're going to cache. Now, why would Varnish be a good match for that, to do that at high scale? Extremely low resource, yes. Very stable, I assume. And I'm talking as a user, not as a representative of the company or or an evangelist for the open source project. I've been using Varnish for decades. I like it. It does all the things it needs to do here, all the bells and whistles. But what I really want to focus on, I think most of the technical part of the presentation will be about a couple of these features. The fact that there's a built-in programming language in which you can change the behavior of the cache and make that play nice with your video platform. Otherwise, modules, you can use third-party libraries. Everything that's written in C, basically, you can wrap around and embed in your system. And even if you don't use any of those, it respects HTTP's best practices. Now, there's this feature I really like. It's called request coalescing. And I'm going to dive a little bit deeper on request coalescing. Now, the danger with lots of proxy servers, not sure if every technology has that problem, is that as soon as multiple users are trying to fetch a piece of content that is not stored in cache, requests are going to be sent to the origin. Now, the problem is if there is no mechanism in place to limit that, that will just be a cache stampede, and that's pretty bad. So what Varnish does, based on request coalescing, is it identifies all these requests as a single request, merges them together, puts everyone on a waiting list, fires off a single request to the origin, and tries to satisfy that. Now, as soon as the first byte comes in from the origin, it gets streamed to every single client that is connected, and at the same time stores it in memory or disk, or based on what you use. That's a quite powerful way. Even if you have only a millisecond of caching, you can still benefit from that feature, which doesn't put a big strain on your origin. So that's one. That is for stuff that is not cached. On the other hand, we have grace modes. And grace mode is basically our interpretation of stale while we're validating. So that means if you're fetching something from the cache that is past its TTL, so that means it's no longer fresh, it should be revalidated. While we're doing that, we'll be sending the old content to the users, and then doing a background fetch to the origin, just one. And while that happens, we still serve old content. Once it's updated, you get the freshest version. Now, as a user, you can even control how that happens. You can enable and disable grace mode, and you can also define how long it can serve past its due time. And if you use HTTP headers, you can use stale while revalidate. That syntax, it's a valid extension of cache control, and I've set it to 100. So 100 seconds past the TTL deadline, it will still serve all data when it's still waiting for an updated version from the cache. But I promised you I'd talk about VCL as well, the programming language behind Varnish. Well, this is it. This is a similar way of doing this. And this is the first introduction to VCL. I'm going to dig a little bit deeper. But let's start off with what's happening, what I marked in red. There's different stages that you can hook into. And right here, I'm hooking into the back-end response part, where I'm going to set the grace mode of the back-end response to an hour. So that means prior to storing it in cache, so the back-end has responded, and you're storing it in cache, then we're deciding the back-end request object, it's just an object we have containing the body and the payload that came back from the server. We're going to give it an hour's worth of grace, and then we're going to store it in cache. So it works both ways. Either you do it the HTTP way, or you have tighter control over it in VCL because your application, your platform doesn't allow it. So that's VCL. But VCL is not a top-down programming language where you can decide anything. It is basically a language that hooks into the finite state machine, the flow of Varnish. So that means you have different stages, and I assume that everyone here can interpret a flowchart diagram. I assume, yes. So you start here, and you always have a request coming in, rec-v, receive. So you receive a request, and then in the end, you have to end up here where you deliver the response. And everything that happens in between is a bit controllable. So that means you have to decide. I've color-coded the lines. Either you go green, which is serving it from cache directly. You go blue. This is a miss. A miss is not bad. A miss is just a hit that hasn't happened yet. So you just, no, that wasn't really intended as a joke. It's a fact. Because there's worse scenarios than a hit that didn't happen yet. And that is a pass that's deliberately bypassing the cache. So all these scenarios, they have default behavior. I have a full day workshop about these kind of things. I'm not going to bore you with that. But you see that there's different stages, different actions, and you can interfere with that by using the VCL language. Now, the thing we try to avoid, but that still needs to be in there, obviously, is this gray box. And this gray box represents a separate thread that involves communicating with the backend. So whenever content, your video content needs to be revalidated, you'll enter this, it'll be a separate thread, and a fetch is going to be made. And either that fetch is going to be successful, and you're going to enter this route, or unsuccessful. Now, as soon as it's unsuccessful, maybe the backend didn't respond in time, maybe the backend is no longer there. Then you're going to send synthetic output under the form of an error message 500, 503, which is going to be fed here. If all goes well, you'll do a fetch. The fetch will respond in backend response. You've seen that already. And then that's going to be stored and delivered to the end user. And that's basically it. I'm going to show you how to dig deep to find an example of It's hypothetical. It didn't come from a client or an actual platform, but just things you can do for video. So we start off by defining with a label which syntax of the Varnish VCL language you're using. That's 4.1 in this case. 4.0 would be just fine, but I'm using the latest and greatest, so I wanted to put 4.1 in there. You define where your backend is. I've named my backend origin. And then you have this hypothetical IP address where it's stored in the port. So it already knows where to connect to. That is the first one that is there. It's going to be used. And when you receive a request, see, we're extending the receiving logic here. If the URL, the request URL, matches a regular expression that starts with /live or VOD, we know we're seeing video, and we want to strip away the authorization headers and the cookies. That could be a way. There's situations where you don't want to do that, but most of the times this is what's going to happen. When something is not stored in cache yet, and it comes from the backend, and it starts with live or VOD, we're going to do this, remove the set cookie, and give it 5 seconds worth of grace. Why 5 seconds? I'm assuming that the segment time of the different segments, the TS files, is 10 seconds. So I'm giving it half a segment time to serve old content while revalidation happens. If we have a live stream, so an M3U8 file for a live stream, it's only going to be cached for a millisecond, assuming that there will be lots of updates. We do at least 1 millisecond, so the request coalescing could still kick in and save us from doing excessive amounts of queries to the backend. But if it's a VOD M3U8, then we're going to cache it for an hour, because that's probably not going to change. So that's VCL in a nutshell, but we're going to dig a little bit deeper. I have 15 more minutes to do so. So there's a difference between live and VOD, obviously. Like for live, low latency is key here. Like no one hates it more than, imagine you're watching an illegal football stream. No one does that, of course, right? And I have and imagine, this is all hypothetical, of course, right? You have an app where you keep track of the scores and it gives you notifications. Imagine that. And knowing that there's latency involved, you could be watching a really cool action happening, player comes in the box, and then all of a sudden you get the notification on the phone and you know it's a goal. So that's bad. That's why low latency matters for live video. But then obviously you get accustomed to it. Like you're watching this, hypothetically, of course, this illegal football stream, and the player comes into the box, you look at your phone, and you didn't get a notification. So that means it's probably not going to be a goal. So it's not really ideal, so that's why low latency actually matters for somewhat legal football streams. So what you'll have in the end is constant playlist updates, because the playlists can't keep a full track of what's happening, because some parts aren't even created. It comes as it comes, so you need to deal with that. So that means you have a low TTL on the playlists. And from a storage perspective, it's quite easy. You don't need a lot of storage because only the X amount of lost segments are required. You don't need the old ones if it's purely live. Now I have these platforms where live eventually comes VOD when it's complete, then you need a little bit of storage. But what I found most interesting, and I don't have an answer to that question, and I hope by coming to this meetup a lot, I'm going to learn more about the segment size trade-offs. You go for big segments, like longer, which increases the latency, but requires less back and forth, less round trips? Or do you go the opposite, keep it as short as possible, then have lots of round trips? I can safely say that it is a trade-off, and I'm looking, like maybe you can help me with that afterwards, what the ideal strategy is, and how to set your TTL accordingly. Now for VOD, it's a little bit simpler because there's no playlist updates, you can have a high TTL, and the fun thing is because the amount of TS files is usually complete, you can already prefetch some of it, put it in the cache. So let's say they're numbered 1, 2, 3, 4, 5. When number 1 is requested and being stored, you can already send an asynchronous request to get the second one, because you know, like a couple of seconds later, the second one is going to be requested. So there's options there. Now the thing is that all segments are required mostly, and it comes with storage requirements. And caching and storage is a difficult matter. Operating systems are not built for caches. Head versus long tail, which is always interesting. The head, that's the hot content, the content that is very popular, the things that constantly get stored in RAM and have a high hit rate. But then you have the long tail. When we talk about video, maybe there's something in your catalog that is not that popular, but still you want to give the user the same quality of experience by finding a way to keep it as fast as possible. So that will probably be stored on a disk, and this will be stored in RAM. How do you deal with that? Well, there's 3 ways in Varnish. Memory and disk are the common ones. One would think that disk would be persistent, but that's not the case. That's also what I learned quite recently. Disk is just more space to store your data in. But when you restart your server with disk-based storage, it won't save it. It will be gone and lost. So that's why, and I had difficulties figuring that out or finding a way to present that in an acceptable way. This is an enterprise feature, and usually things happen in the open source, but it's very applicable to video, so I wanted to show you that. I have something in the end for you as well that will soften the blow a bit. So MSE, Massive Storage Engine, is something we invented for video clients or large volumes of content, which is actually a trade-off between disk and memory. So there's this top layer that has the number of gigabytes of memory you assign to it, and then the disk layer below is actually the secondary origin, so to speak. So when Varnish doesn't find it in memory, it falls back to disk. Now, disk is not your typical operating system kind of file access, because file access is something we try to reduce, and also directory iteration, especially on large volumes of content, is also something we want to reduce. So what we have is pre-allocated large files on disk that are constantly kept open and that we're actually streaming the data through with an efficient LRU algorithm, making sure LRU, who doesn't know what LRU stands for? Least recently used. So that means the content that is not as popular. So the least popular content needs to get thrown out of the cache. And by doing this, especially on disk, you have fragmentation. So we try to find the balance to do that. And instead of keeping on talking about these bullet points, I'm going to show you how that works. So at the minimum, you can do this. You can set 100 gigabytes of storage, will be stored in RAM, and that can be served. But you want a little bit of persistence, or maybe you need more than 100 gigabytes of space. Maybe your servers have limited amounts of RAM, and you want to use the disk. So what you can do then in the configuration file is start adding books and stores. And books are LMDB databases, just really fast memory mapped files in which you hold the metadata and the journaling. It's a really tough word, a metadata database. Tough word to pronounce, especially for a non-native speaker like myself. So we assign a gigabyte, we store it here, whoops, and then we assign stores to it, and those are physical places where data is going to be stored. So this is one DAT file that's going to be 2 terabytes in size, and we're going to stream data through there. Specifically, these TS files from HLS. But we're tagging them with their properties. We're tagging this one as slow and SATA, because this is a SATA disk, 2 terabyte SATA disk. But maybe you have an SSD, half a tera SSD that is stored here. And by default store is none. That means if you tag something as none, it'll be served from memory. So how do you actually use it? You create a file system with a custom binary that is included and that links to it. And eventually, you'll link the configuration file to the running process. And all of a sudden, you have MSE support. Now, by default, the storage is distributed in a round-robin fashion, meaning that first the one is going to be selected, then the other is going to be selected. But there's ways, again, in VCL to interfere with that. So you can set the weighting based on size. So the biggest one, the biggest disk, gets the highest priority. But you can do it with available as well. The disk that has most space available will get most of the inserts. Or you can do it in a smooth fashion where you can combine both. That's how it works. But it gets really interesting is when you start adding specific business logic into it, or logic specific to your platform. Imagine this one. We're hooking into the backend response. Again, things come from the backend, and we're going to store them. What is going to happen? If we notice that the TTL that could be set through a cache control header is less than 2 minutes, then this data is very short-lived. So it doesn't really matter if we store it on disk or not. We're going to set it to store none, so that means it's going to be in the volatile cache. It's going to be in memory. And when it passes its TTL, it's not longer going to be there, and revalidation needs to happen. Otherwise, if the content length of the thing we're trying to get is larger than a megabyte, then we're going to, and of course the TTL is equal to 2 minutes or more, we're going to store it on our SATA disks. And if it's smaller, we're going to store it on our fast disks. This is just an example. And if we have no clue what the size is, because it's chunk transfer encoding, so data stream through, we're just going to throw it in there as well. So it gives you the options to play around with that. So that's storage. Storage is not easy in caching. We're giving it a good try. It seems to work out well for us, and we're hoping to put that forward. But what I find most interesting about Varnish, I'm more of a web application person than a video person, is making decisions at the edge, which is a very expensive word. Of the edge is the outer tier of your web application platform. So that could be your Varnish, your CDN, or any other reverse caching proxy that you're using. But I try to make it as applicable as possible to video. So I found another really expensive word, digital rights management. I added a little asterisk there because in the example I've built, like the little FFmpeg example, it was just authentication. And you point in your M308 file to a place where the encrypted TS files, here TS files are encoded, they have to be decoded by the player, that endpoint where the encryption key is stored that you use to decrypt. So what you could do is you could say, yeah, the encryption key definitely needs to be protected, because if anyone has the decryption key, you could go ahead and decrypt all these files. So you don't want that. So I created a really stupid, idiotic example, but it should prove the point that you can offload basic authentication at the edge and make sure it doesn't have to pass through the origin. So basically, the authentication doesn't happen at the origin, meaning it is cacheable. Because if the authentication is supposed to happen on the origin, you can't cache that, because it's an individual decision. So what I'm doing here is, if we receive a request and URL contains live and then encryption key, the encryption key, we're going to check an authorization header. It has to be basic authentication and this base64 hash. In case you can't memorize base64 encoded hashes, this is just the base64 representation of admin, admin. It's admin, admin. Please memorize that in the next couple of seconds. If that happens, if the authorization header is not this one, it means the user isn't properly authenticated. And we're going to synthetically say 401 restricted. This is going to trigger the synth logic, so that means we're going to end up here. And if we notice that we're getting a 401, we're going to set this www authenticate header, which will cause the browser to spin up this server-side pop-up. It'll give you the opportunity to log in, and you're done. But again, it's pretty idiotic. Like in reality, you're obviously not going to use that. It doesn't scale well for a big user base, but maybe in some exotic cases you might use that. What I really wanted to show is that you can take it to the next level, this authentication, and you can offload that maybe to your regular web logic, where you're going to store sessions, perhaps in Redis. Who's heard of Redis? Redis is a key value store. It's super fast, and it's not part of our open source project. It's a separate project, but we have modules to integrate with that. So imagine that you have a PHP website. I come from the world of PHP. I won't apologize for that. And you have this login procedure, and you save the decision for a user, if it's an authorized user or not, in your session store. This session store could be hosted on a Redis, and then from Varnish we could fetch that. Let me give you a brief example. You load a couple of modules, you define where your origin is at, and then at the initialization of Varnish, we're going to initialize a Redis connection. This is Redis. It's hosted on this hostname, coming from my Docker setup, so it could be any hostname I choose. This is my port, all the parameters. But what I've also added here is a key value store, a local key value store that is part of the Varnish installation. Because although Redis is super, super fast, you sometimes want to avoid doing TCP/IP connections on a large scale. Could be a bottleneck. So what I'm doing here is, if I don't have it in this key value store, I'm going to fetch it from Redis. When I fetch it from Redis, I'm going to store it in the key value store so that next time I don't have to do that TCP interaction, TCP/IP interaction with Redis. So here it goes. I'm assuming that I have a session stored in Redis for that user. So when someone is trying to fetch the encryption key, I've color-coded it for your convenience. Dark red is everything involving our key value store. Green is everything involving our Redis access. And blue is anything involving cookies. Because if you use PHP sessions, it's going to set a cookie for you. And that cookie is called PHP sesID, session ID. And it contains a hash. And that is your unique identification of your session. That was done by a third-party application. So if we notice that the cookie we're getting, that the backup value is empty and that value is actually empty, we didn't find it in the key value store. So that means you have to talk to Redis. There is a prefix in PHP, PHP Redis _ session, and then comes the value from the cookie. We fetch that from Redis. And if we find it, and the value is not equal to authorized B1, this is just the serialization format of PHP, meaning that this is the variable, this is the data type, it's a Boolean, and 1 is the value. So that means authorized equals true. If that is not the case, then you're not authorized. And then we're going to set the key value store to false, meaning that the next time we come around, we already know you're not logged in. And we save that decision for a number of seconds. If that happens, you are not authorized. Otherwise, you are authorized, and we're going to keep that decision for 10 seconds. And if it turns out you are part of this key value store, you already stored the data there, and it's false, you're not authorized, and under all other circumstances, you can actually get the encryption key that allows you to decrypt those TS files. So this shows you that technology like Varnish, and more specifically the VCL language, allows you to dig in deep and make decisions at the edge that otherwise should happen at the origin, which will save you lots of bandwidth, I/O, CPU, you name it. I have a couple of more examples before we end. I think I have 5 more seconds before my time is up. There's geo features involved in there as well. You can set up a big old geo fence. You use the MaxMind database, a very common database that associates IPs to locations. And then you could use that and say, if the country name that was fetched from the client IP is not Germany or Belgium, then you're not allowed to watch it. Geofencing, but you can do different things with geo as well. You can actually dynamically choose a location. Let's say you build a CDN, and this is your point of entry. We're initializing GeoDB, and we have a US location, a UK location, and a Belgium location. I'm Belgian, by the way. That's why I'm including this very weird anonymous country from there. Yeah, I'm from there. But there's more Belgians there. I think there are 2 more Belgians in the room. More? Yeah, a lot more. Cool. Let's say you receive a request. You get the client IP. You get the country code based on that module. The country code gets saved in this custom request header. If that turns out to be the US, you set the backend hint to US, which refers to this backend. So you get the trick, right? If it is Great Britain, you go to the UK site. You redirect to that origin. And under all other circumstances, you route to Belgium. So these are different ways of using geo at the edge. Now, I know that a lot of CDNs offer this as well, but if you decide to go for software solution or for a local CDN, this could help you quite a bit. Now, I've been talking about origins and backend servers for quite a while. You can also avoid that, like use a module to avoid using any origin. And basically, just fetch it from the file system is what you can do. Now, we're not going to pretend that Varnish is a web server. We're not a web server. We're a full-blown reverse caching proxy. But you can actually load stuff from disk and use it as a backend. So the first time you get it, and it's not stored in cache, Varnish is going to get it from disk. It's going to store it in memory. And the next time around, it's going to be fed from memory. So all these, these are just examples. You'll have to find your own way when you use the technology to get what you need. But I'm just throwing in random examples. Maybe video segment prefetching. You could do that as well. We have a module that wraps around curl. And we all know curl, the HTTP client we all learn to love most of the times. It's wrapped around. So what you can do here, if we notice that we're getting a video on demand segment that ends with TS, we actually have a TS file, a video file coming in. Those are usually numbered, or in a lot of cases numbered or prefixed in a way. All of this allows you to do this magic function called prefetch next URL, and there's a little bit of logic in there that tries to guess the next URL, and it's going to fetch it already. So if you get segment number 1, it already is going to go for segment number 2, and so on and so forth. And it's going to do this in the background, making sure your cache is filled. I have more examples. I'm going to throw in the last example. Rate limiting and throttling is also something you can do at the edge. You can decide that if a client does 15 requests, more than 15 requests in 10 seconds, you're going to block him for 60 seconds and say too many requests. But what you can also do is if you let that user through, maybe you add a little bit more logic, you can throttle the connection speed to 1 megabyte per second based on all that. Now, those were a bunch of examples, most of them applicable to video. It just goes to show that VCL is a quite flexible language. That is part of Varnish Cache, the open source project, also part of Varnish Enterprise. And a lot of these examples use vmods. There's an ecosystem for that. You have a bunch of open source vmods that you can compile. You can write them yourself, or we have some that we maintain. Now, I promised to soften the blow. This is where we end. A lot of what we have is pre-packaged in the cloud, so that you don't have to set it up ourselves. Our engineers have built it, tailored it, both for open source and enterprise. And if you want to play around with the enterprise features, I'm not going to force you to buy an enterprise license. I'm not a salesperson. I'm a technical evangelist. So we have it license free here in the cloud. There's just a little bit of the typical marketplace stuff in there. It allows you to play around with it, and it's 2 weeks of free trial. That's it. Thank you for sticking around. Thank you for not running away. I know you were waiting for the book, and I'm going to let Phil handle this either right now or at the end. Either way, thank you. It's always good to be here. See you next time. Bye.